Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 6.6, Calculus using inverse trigonometric functions. This inverse trigonometric function calculus, essentially what I'm going to teach you is how to differentiate the arc functions. It's essentially algebra rearranging, where you just rearrange the x and y into a normal trigonometric function, then you differentiate it with respect to the correct variable, then do a implicit differentiation technique, and you will end up rearranging into some expression of just x. So this whole thing might be given in the equation booklet. It was given in the old spec equation booklet. I'm not sure if they changed the equation booklet for this specification or not, so I can't say for sure. Anyway, it's good to know how to derive, and I'll show you how to derive the expression. Like last video, I'm gonna do it for arc sine, and you guys would do it for arc cos and arc tan. So let's get this party started. The first thing we do is, because we have no idea how to differentiate this arc sine business, we swap it to the other side such that we have x equals to sine y. This applies because we're just inverting the inverse trig function, so we get back to the normal trig function. Right now, what we can do is to differentiate both sides with respect to x. So if we differentiate both sides to x, then x differentiated with respect to x, so x by dx give us just straight 1. Now this is the problem. We cannot actually differentiate sine y by x because this is not a value of x. However, we can use chain rule. So if we write down dy by dx, dx by don't do the dx, but d by dy. So if we cancel the dy's, we get d by dx, which is differentiated with respect to x, and now we chain rule the y into it, so we have the sine y as we normally do have. However, this time we leave the dy's intact, so we have dy by dx multiplied by d by dy of sine y. So differentiate sine y with respect to y, give us plus cosine of y. Remember, we're not integrating, so it's still positive. We still have the dy by dx, so we'll leave the dy by dx over here. So what we have here is an expression of the differential of arc sine. So this is the gradient function, and we need to rearrange everything away from the gradient function, so we get 1 on cosine y is dy by dx. But what we essentially we're done here, but what we really want is an expression of x, because we're just expressing we have one variable essentially. This is our only variable x. Y is just a symbolism kind of thing. You can write it as wfx, whatever. What we're interested in is in terms of the expressed term, what this arc sine is. So there are multiple ways of converting cosine y's into x's. The most straightforward one would be to turn it into the by using an identity called 1 equals to sine squared plus cos squared. So we all know this equation. It's written in our brains anyway. So in order to get an expression of cosine, we rearrange such that 1 take sine squared is cosine squared, and take this massive square root. We have cosine as 1 take sine. I deliberately ignored the term because it can be anything. So we have a simple root of 1 take sine squared. If we substitute this in and keep the y in place, we have 1 on square root of 1 take sine squared of y. And guess what sine squared of y is? From this hint, it goes to another space, aren't I? Let's write it here. Equals to 1 on the square root of 1 take x squared, and that would be the entirety of dy by dx, which is also the differential of arc sine. So now we have a beautiful expression. We can repeat this process with cosine. For cosine, this is very much the same. However, for arctan, it might be slightly more tricky. You will require to use a different. Well, you use the same equation, same identity, but it's in a different format. I'll let you experiment with that. This is very controversial to a lot of teachers, but I am gonna go this way. I'm gonna say, for this particular thing, it might be best just to learn the formula, because it's not in the spec such that you need to derive the inverse trigonometric functions. If you're going to be a mathematician, an engineer, or a scientist during university, by all means learn the derivation. It's going to be very useful, helpful in a lot of ways, and it's a very good algebra practice. But in a nutshell, not very important to thoroughly understand how the arc functions actually work during differentiation. As long as you know, because these are standard solutions, you can just pluck it out from thin air and no one would question, as long as you write down from standard results. And so it's really it's a thing to bear in mind. The derivation is a thing to bear in mind, but not essential. Also, this is a more practical tip, which is the arc sine function is used more than the arc cos function. They look relatively similar. They are basically practically the same thing. But most people use arc sine rather than arc cos, so if you only learn arc sine without learning arc cos, fine by me, fine by a lot of people in fact. Arctan, however, is different, so you do need to know. Yeah, that's it for this ramble tips, but yeah, basically, if you wish to learn it, go ahead. I'm not stopping you. But for A-level purpose, for most people, it's not worth it. So, yeah, basically, do what you wish. Okay, so as I said, you're gonna do the arc cos and arc tan by yourself. Arc tan would be slightly more difficult, but it would essentially be exactly the same. you know the standard differential of tangent is sec squared. That's my tip for you. Yeah, basically that's all for this question, so I'll give you, as usual, 5 seconds to pause and do the questions, and I'll show you the answer in 5, 4, 3, 2, 1. Okay, the solution is shown right here. So the arc cos turns out to be negative of arc sine, which is also the reason that people prefer to use arc sine rather than arc cos, because you can essentially just put in a negative coefficient rather than a addition coefficient. So it's essentially the same exact thing. So yeah, basically if you want to answer in terms of arc cos for a questions that has a standard answer of arc sine, I don't think anyone can actually penalize you for doing that. So if you wish to play with life, go ahead. For arc tan, however, you need to use the trigonometric identity where I think it's 1 plus x squared equals to 1 plus tangent squared equals to sec squared. That is essentially just dividing the original trig identity by cosine squared, I think. Yes, it is. So if you do that, then you would get the expression 1 on 1 plus x squared as your solution for this question. So there aren't, again, it's relatively straightforward. It can be challenging if you are kind of not that good at algebra, but again, you can just remember the standard solutions because they are relatively easy to remember and they are frequently used, and for most scientific papers you would be allowed to use these standards without even quoting what you're doing, so which is very, very helpful in a sense. But yeah, basically that's all I want to say. That's it for this video. Thank you very much for watching. If you have any questions to do with inverse calculus, inverse trig calculus, that is, do let me know in the comment section below. But yeah, that's it for now. Thank you very much for watching, and I will see you on my next one.